Now let's move on to circular motion. So, uniform circular motion is when an object travels around in a circular path with a constant speed. Alright? So, maybe if you are driving around a roundabout, not necessarily, trying to stay at a constant speed. Alright? So, have a look at the diagram that we have down below. Those little orange arrows on the dotted lines. So, these ones here represent the direction of the object, and then this blue ball is the object. What you might notice is that the orange vector, velocity, is always acting tangentially to the dotted line. So in other words, it's kind of has the same gradient or the same direction as the dotted line at that point, but then goes off in a different direction. The other thing you might notice is that the force is always acting inwards towards the center of motion. So, these are really important principles that you need to remember. The velocity always acts tangentially to the motion. The centripetal, which is what we call it, centripetal force, acts directly towards the center of motion. And it acts perpendicularly to the velocity. So the force, the centripetal force, and the velocity are perpendicular, which means there's a right angle between them, 90 degrees. The other thing which isn't shown in this diagram is that, remember, acceleration goes in the same direction as the force. So the centripetal acceleration would also be drawn towards the center of motion. So I want you guys to pause the recording and have a quick think about why this might be. Why does the velocity not even go in the same direction? Why is it not just following around the dotted line? And why is the force acting inwards? So, I want you guys to imagine driving around a roundabout, alright? And say you're going really fast, you're being an irresponsible driver, you're driving really fast down the roundabout. As you're going, how do you feel yourself being pulled? Alright? Where do you feel like you're being pulled? You feel like you're being pulled away from the center of the roundabout, right? So imagine yourself in a roundabout, you feel like you're being pulled away from the center of the roundabout. Why is that if the force is acting towards it? It's because your body resists that change. The force is acting towards the center, but your body is resisting that change, inertia, and because of that, it's acting in the opposite direction. An even simpler example is if you are just driving along a straight road and you accelerate a lot. How do you feel? You feel like you're being pushed back into your seat. Even though the force is going forwards, your body is resisting that change and you feel like you're going in the opposite direction. So that's why the force is going inwards, alright? Now let's have a think about this. Why is the velocity vector not just following around the circle? Well, have a think about driving around a roundabout when it is a cold day. Maybe there's some snow, some ice on the road. If there's a big sheet of ice and you're driving around the roundabout and you hit the ice, what's going to happen? You're going to skid off in the direction that you were driving at the instant that you hit the ice. Alright? You're not going to keep going around in a circle because you've lost traction. So, what's really happening is when you're driving around a roundabout, your car and yourself constantly wants to go off in the direction of those velocity vectors you can see. But the friction between the wheels and the road is keeping you on that circular path. Alright? Your body, the car doesn't want to go there, but because the wheels are holding onto the road, you're going to keep going in a circle. But as soon as there's an icy sheet and you lose the grip, right, then your car's going to skid off in the direction of that velocity vector. So that is how you can conceptualize all of that. So recap, velocity tangential to the direction of motion. Force is perpendicular to that, towards the center of motion. Acceleration perpendicular to velocity again and towards the center of motion. Alright, now let's get into some important equations that you need to know. So, we have V is equal to 2 pi r divided by t. R is the radius of the circular path, and t is the period. So the period is how long it takes for one revolution to be completed. Say it takes you 5 seconds to do a whole U-turn around the roundabout, then the period is 5 seconds. Alright? Let's move on. The centripetal acceleration is A equals V squared on R, and that acts towards the center. The centripetal force is equal to mv squared on r, and that also acts towards the center. So, whenever you are solving questions and you're figuring out these values, make sure that you always write the direction, which is going to be towards the center for the centripetal acceleration and the centripetal force. Alright, let's get into an example. So here we have a car with a mass of 1,000 kilograms traveling around a roundabout with a radius of 10 meters at 60 kilometers per hour. Calculate the acceleration of the car along the roundabout, calculate the net force on the car, calculate the time the car takes to go around the roundabout, and then what would happen if the force required, what would happen to the force required if the car speed doubles. So, I want you guys to pause the recording and have a quick go at this question. Even if you are not familiar with circular motion at all, I'd like you guys just to kind of have a quick go, at least. Just so that you can practice using those formulas. And, you know, really see and kind of at least try to understand what's going on. But otherwise, I will go through the solution for the question now. So, the first thing we're going to start with is part A. Calculate the acceleration of the car. So we know the mass is 1,000. We know that its velocity is 60 kilometers per hour. This is not in the correct units. Always keep an eye out for when things aren't in meters per second, or they're not in meters or seconds. Always look out for that and make sure that you are putting these into the right units. It's really important, and it's a really easy thing to miss too. Kind of, it's almost to the point where as soon as I see any kind of speed or weight or anything not in the QCEE physics units, it kind of rings alarm bells, even if it's completely unrelated. So yeah, you need to make sure you're looking out for that. So what we need to do first is we need to convert this into meters per second. So 60 kilometers is how many meters? Well, we're going to multiply it by 1,000, and that will give us 60,000 meters. Now we have hours down here, but we want it to be in seconds. So how can we convert hours into seconds? We have 60 minutes in an hour and 60 seconds in each one of those minutes. So this is going to be our conversion here. Which gives us 1.67 meters per second. Alright, we need to find the acceleration of the car. So let's have a look back at our formulas. Our acceleration formula is given here. A equals v squared on r. Right, so we're going to have 1.67 squared. I believe our radius was 10 meters. So this will give our velocity, sorry, our acceleration as 0.28 meters per second squared, and that is going to be towards the center. Right. Now let's move on to the next question. Calculate the net force on the car. So, to do this, we could use F equals ma. Right. So, we can have 1600 multiplied by 0.28. Now you might be thinking, why am I not using the force equation given before? And that's because we already have the acceleration. If you have a look at our force equation, it's actually just a combination of F equals ma, but for A, they have substituted in the A formula there. Alright? So that's why we only need to use F equals ma here. That's not necessarily super essential, just interesting to know. 448 newtons, and that is going to be towards the center too. So that arrow should be in the opposite direction, towards the center. Next, calculate the time the car takes to go around the roundabout. So that is going to be the period. Because remember, the period is the time it takes for the particular event to occur. So, to find our period, we need to have a look back at some of our equations, alright? Namely, our velocity equation, because this is the only one that has the period in it. So the velocity is equal to 2 pi r on t. So, our velocity is equal to 1.67. Our radius is 10. And we can solve for t from here. This gives us 37.62 seconds. So that is how long it would take for the car to go around the roundabout. Last part, part D, what would happen to the force required if the car speed doubles? If friction between the tire and the road is unable to provide this much force, what will happen to the car? So, let's deal with the first part of the question. What would happen to the force required if the car speed doubles? So, our velocity is, instead of 1.67, it would be double that. Alright? So, our force required is equal to mass times v squared on r. Right? If we double that velocity, we're going to have m 2v squared over r, because we're putting in 2v instead of v because it's doubling. Right, let's see what happens. We're going to take the 2 out. We're going to have 4mv squared over r. And as you can see, F2 is 4 times that of F1. Because we have this 4 outside here for F2, but we only have a 1 outside there. So if you double the speed of the car, then the force actually quadruples. All right? So that's just kind of a simple way of figuring out those kinds of questions where it will ask you, you know, if this particular value increases by this much, then what will happen? All right? So all you need to do there is you just need to substitute in that change, take the change and kind of put it out the front of the equation like we did with that 2, and then see how it compares to the original. So the next part of the question is, if friction between the tire and the road is unable to provide this much force, what will happen to the car? So going back to our ice example, all right, think about it like this. If you're driving around a roundabout really, really slowly, snail slowly, and there's a little bit of ice, you might be able to maintain traction and still go around. And that's what you do if you saw ice on the road. I mean, maybe you just wouldn't drive over it, but if you were driving over it for some reason, you might go really, really slowly, and you might get around. But think about it again, if you speed up, the force required to keep you on that ice actually increases, and that's what we saw in that last equation. So, if the force required is unable to provide this much force, then the car will skid off. Alright? So you could even think about I was going to talk about cars rolling over, but I don't think that's super relevant, so we'll just leave it at that. Alrighty. Let's move on to our next topic, which is gravity.